Yes, sir. Can see.
Okay, good. All right. Now, before our class, before this, I think last class, we learned about transformation matrix. So when we use transformation, we will have something local on the left, and then a converting factor, or we call it transformation matrix here, and then we continue with the global entity. Okay, so if you use transformation matrix T, make sure you're referring to the same parameter. For example, if you look at displacement, d prime on the left, local, all the local we use prime, d prime, then on the right hand side here we also use displacement, right? D. So if you use f prime force, then we will use the same transformation, and then on the right we also use force. Only the difference is one is local on the left, one global on the right. So so if you can remember this one, then it will be good for your coming exam. And then another one is the normal equation that we learned since chapter 1, which is F equal to KD. Right. So this fixed already. Yeah. So when you see K and with the left and right matrix, then it will link with force and displacement. You always have in this case, yeah, F equal to KD. But if you use transformation T, then you have to use the same parameter. It referring to the same parameter, for example, displacement and displacement, force and force. Okay, so this is the fundamental principle that we should remind ourselves every time we deal with finite element analysis. Okay, so what we've seen so far is that we have transformation matrix in 4 times 4, means 4 row and 4 column, and our K prime also in this form. So we have built our K before this, and then K prime on the right hand side of your screen, and then yeah, in the bottom here, K, right? K equal to AE over L, and then the input for your matrix, right? So C represent cos, S represents sine. So if you see the C square means cos square. And if you see in your stiffness matrix, you see the AE over L, it tells you that you are analyzing a bar, not spring. Spring, you don't have this one. Yeah? Spring, you can take out this one. You only use the middle one, this one. Yeah. So this is what we learned so far. Today we're going to learn something, and we'll go through one example tutorial. So make sure you go through that one. Today we're going to look at stress analysis. How we determine stress. So for example, okay, this one will be in your tutorial question number 10. Huh? So it will be your tutorial question or your handout chapter 3 question 10. Yeah, you'll get the same diagram as what you see on the screen now. So again, we are having a bar. So the word bar, again, when you see the bar, you always will have F equal to AE over L times your displacement. All right. So always you'll see AE over L. Okay, remember this one. Now on the screen you see there's a bar, and with 2 point 1 and 2, or node 1, node 2, and the direction, our direction is referring to X prime, which is our local axis here, X prime, and all the displacement was along our X prime. So how we make our notation in our calculation, in here you see the F means we are referring to force at point number 1. F prime means referring to a local axis. F prime 1x means the force at node number 1, along x-axis, and the x-axis is the local axis. Yeah. Same with the f prime 2x here. F prime 2x means the force, there's a force at point number 2 along your local axis, okay, in x direction. So the length of this bar from point 1 to point 2 is given by L. And x and y axis here is your global axis. Yeah, global axis. Okay, how we link what we learned so far. So again, we call back what we learned, F equal to KD. And we expand, oh, it's a square. And we expand the equation according to a diagram here. So if you look at the diagram, we have two forces. So we write F prime 1x on the left-hand side, F prime 2x on the left-hand side. So again, this component is your local prime. We're looking at local. So this is your stiffness matrix K, and this is your local displacement. Yeah, local displacement. So I think this one is quite straightforward. Same with the previous chapter that we cover. So only when you see bar, your stiffness matrix, you have AE over L, 1 minus 1 minus 1, 1. Okay. If you are having a spring, then you use back the Hooke's law, F equal to Kx. Then all this 1 will replace by K. You have K minus K minus K and K. And then you don't have A over L here. Okay, there's a difference between spring and bar. Yeah, so don't confuse between what happens if you see K minus K minus K K. Yeah, so this kind of matrix for spring, and then if you see A over L, it is for bar. Yeah, so don't confuse. Okay, recall the definition for tensile test. Tensile stress. Tensile means there's a pulling force on both ends. So stress, the word stress itself, give you by sigma equal to force divided by area. So in this case, we are looking at a force at point number 2. So you write tensile stress sigma equal to F prime 2x divided by A. A is a cross-section area of this bar. Yeah, if you cut this one, you might be seeing a cylindrical, you might be seeing a square, right? Or sometimes hexagon, a pentagon, and so on. Right? So be familiar with the equation of the area for cross-section for circle, square, all right, so this square and circle is quite popular shape, so make sure you know and be careful when you read the question. Okay. So if you write the equation for f prime 2x, all right, you extract the equation from what you derived just now. Purposely for 2 prime 2x, you can write f prime 2x equal AE over L, and then minus 1, 1, and your displacement U1 prime, U2 prime. This one you extract from this one. Yeah. So how you get this one? You from the matrix equation you have, you're looking at F2x. So what you do is you're looking at this one and this one. Again, recall how you derive the equation. So if you want to get the equation for 2 prime 2x, you times AE over L minus 1. So this one times U prime 1 plus AE over L U prime 2. So this is how you do it. Huh? So this one times this one plus this one times this one. Huh? So of course you can factor out once you're familiar with the system, you can factor out this one and then you just do the expansion of the equation. Okay. So we write in the matrix form. How we write our matrix form, we transfer our force into stress, right? So if you look at your screen bottom left here, the force you convert into stress, because our stress equal to force divided by area. So what you have on the left hand side here, the whole equation you divide by A, and this one you divide by A. So A cancel A, you only have EL, E divided by L, and then minus 1, D prime. Okay. Any question on this slide? Any question want to ask me? Anything that you're not sure? Ask me now. Katana, you okay, yeah?
Can you come again on the stress, the last equation?
Which one? This one.
Yes.
Okay. Do you understand, Katan, do you understand how you get this equation?
Yes.
Okay. So do you understand this equation?
Yes.
So can you relate stress equation and the force equation? You want to write this, you want to substitute this whole thing
Oh, I
inside
see.
here. So you substitute here, you get stress equation. So because your stress equal to force divided by area, so this force matrix equation you divide by area, so you take out the A. So at the end you arrive at this one.
Oh, I see.
Okay. Now this one is just displacement, so it's a D prime. So this is a general form for our matrix equation. So of course, on this D prime means all the displacement you have. You can write U prime 1, U prime 2 when you expand. Okay. Yeah. Right. So this component is D prime. All right. So let's move on. So now we have the stress equation. Stress equal to E divided by L, and then your stiffness matrix here, D. So D prime. So again, when you see the prime symbol here, it means you are still referring to local dimension. Okay. The next one, you need to recall the previous definition for transformation matrix, which is when you link your D prime with the transformation matrix T and the D. So this is what we learned in our previous lecture. So if you forget about this one, go back to the previous slides. Yeah. Okay. So you substitute this information into this first equation on the screen here. Then you arrive at the third equation on the screen here. This one. Yeah. So the rest is just simplification. You can write in the simpler form where we'll use a C prime to represent this one. Okay, because it's quite lengthy if you have a lot of equation to solve. Then we will simplify E divided by L, 1 minus 1, and the transformation matrix. This whole set we can write as C prime in our derivation. Okay. So when in the test, don't straight away write C prime. You have to derive, or you have to write this equation out, and then followed by this equation. Right? Don't in your test or exam, don't suddenly you write C prime. Right? You have to write the above equation here, and then you continue with the C prime for your calculation. Okay, and then the rest is just substitution. Right, we start with the first equation, this one, and then we keep substituting what we learned before this. The first substitute equation we use is d prime equal to transformation matrix times the displacement. The second one will be using what we learned so far for t star. We have this form CS 00 and 00 CS. Then we will substitute inside there. We will get C prime equal to EL times 1 minus 1 1, and then times your T star here. So because your T star, you substitute here, and then this whole equation will no, and then your C prime will be on the screen. Yeah. Okay, this whole thing is your C prime, and recall the definition of your transformation matrix. So you just rewrite your C prime. C prime equal to E divided by L 1 1, and then your CS 0 0 0 0 0 CS. Then we move to the next slides.
So just
yeah. Go ahead.
So where's the displacement in this last equation?
Again, your question?
The displacement in this last equation.
You mean this one?
Yes.
This is, we only focus on the C prime. We are looking at this one. We are not looking at the overall equation.
Oh, okay.
Okay. Of course, you want to write this whole thing in this equation also can, but because it will be a bit messy if I write everything on the screen, and yeah, it will be more complex. It look more complex. Actually, it's a simple thing, but I don't want to confuse you guys. Okay. Yeah. So okay, so what important equation for today is this one. This one. Remember what is your C prime? Your C prime is this one. Then you do substitution. Okay, you do substitution into this one. Okay. Now, just now, what we learned is stress equal to your C prime matrix times the displacement. Yeah. So again, you need to recall what is your C prime. C prime, your C prime is equal to EL, E divided by L 1 minus 1, and then times the cos and sine matrix. So again, yeah, call this your C prime. And when you multiply, you do the expansion, you will get the product of what you have. So if you expand your equation, you will get this form. Yeah. All right. So how to do the calculation? If you take how to do this kind of calculation, refer back to your calculus. Yeah. How to transform this one to this one, refer back to your calculus. Yeah. All right. Now, your C prime will become E over L minus C minus S and CS. Okay. All right, we look at one example. This example is your question number 11 in your handout. Yeah. So what we have here, we have a bar that slanted 60 degree from your global axis X, and other information are given in the question. So you have an area, a cross-section area of 4 times 10 power negative 4 meter square. Your modulus Young or elasticity constant value is 210 gigapascal. The length is 2 meter, which means 0.1 and 0.2 is 2 meter. And let the angle between x to x prime is 60 degree. Assume global displacement have been previously determined. So you are given the global displacement value u1 equal to so and so, v1 equal to so and so, v2 so and so, u2 and v2 value is given. Yeah. So before we start, you need to know what is the question asking for. It asks you to find axial stress. What mean by axial stress? Axial stress means your stress that along the axis. Yeah. So let's say you have a bar and you have an axis. So this means that let's say you have an axis of x prime. So if you have a force that parallel to the axis x prime, then you are having, let's say you have a force. Yeah? So you have this force, we call it axial force. Okay. And of course, this force, when this force is perpendicular to the surface area here, it will become normal stress. Okay. Stress equal to force divided by area. Right. So these are the things that you learn in your static module. So recall what is your C prime. So you start with the C prime equal to EL, E over L minus C minus S and CS. Yeah, this is the first equation you call up. And you start to substitute all the value. Okay. Yeah. Katana, what is the value for C? Can you calculate? Lie and you calculate for S. What is the value for C? Katana? Okay. Singi, you stand by. Or what is the answer for C? Just in case Katana not able to answer.
So the previous lesson, at this point, my internet went off, so I didn't really understand much. But I know about the matrix, but the values not yet.
What do you understand? What do you understand about the C? What is C means to you?
Actually, sir, I don't know.
Just now I did mention. Okay, Singi, what is C in the question? In the equation, what C means?
Cos.
Cos. So what is the value for the value of C? Katana, please go back to the video recording to review what we have covered so far. Yeah. So the material is online, so there's no reason why you don't know. Yeah. So
No, sir. It's an abbreviation for cost and sine, right? Okay, now I remember a little bit.
yeah. Okay. So what is Singi? What is the value of cos?
Is it cos 60?
Yes.
The
correct.
answer is cos
Cos 60 equal to what?
0.5.
Yes, correct. Okay, Lai, what is S stand for?
Sine.
Sine. So what is the answer for the sine value in this case?
0.866.
Okay, good, excellent. So all right. So the rest is just substitute. E value is given. So E is 210 giga. Giga is 10 power 9. L is 2 meter. So again, before you solve a question, make sure you are using the correct unit. So in coming test or final exam, we will change all the unit to a non-standard unit, which means you will see mm, you will see cm in a question. In this case, you will see the mm in this case, like for example, your U1, V1, U2, V2. So you see mm. So you need to convert into meter when you solve later on. Okay, so you substitute all the value. So for example, the cost just now given by you. So cost equal to C means cost 60, in this case 60. So of course in exam we will change the value. So cos 60 equal to 0.5 and sine equal to 1 point something, right? So it's good that you can remember the fraction form. So it will help you to solve the question a bit faster in some case. But if you put in decimal place also okay. Again, for this module, maximum 3 decimal place. All right, 3 decimal place, minimum 2 decimal place. So again, call back the displacement component. So D equal to, you have 4 displacement here, you have 0.1 and 0.2. So what mean by U1, right? Again, when you see U1, it just means that U1 means you're referring to 0.1, and if you write U, you refer to global axis, yeah? If you write U1, refer to global axis. If you write V, you refer to global axis of Y. And again, if you're referring to X prime, you have to use the prime, yeah? So of course, in this case, we use the D because all the displacement are given. So your D, you write in the unit SI form. So unit SI form, for example, U1 equal to 0.25 mm. You rewrite in the unit SI form, which is you have 0.25 times 10 power negative 3 m. Right? V1, you don't have V1, 0. And U2 and so on, you just convert into a unit SI and put them in the matrix form. Okay, so far everything is quite straightforward. Then call back the stress general equation. Stress on the left hand side equal to C prime D. This is the equation for stress calculation. So stress equal to C prime times D. So you already have the C prime. So you just substitute inside this general equation. D, you just put back this equation. You put back this equation. You put everything together. And then you do the calculation, right? The rest is just a calculation of matrix. Just time inside there, and then you get one value. Okay. Okay, so this one you have 1 times 4 matrix. This one you have 4 times 1 matrix. So at the end, you will get 1 times 1 matrix. You get one answer for the stress. Okay, and again, if you don't know what is 1 times 4, 4 times 1 matrix, then you really need to go back to the calculus module and look back at the definition of matrix. Yeah, so you will not be covered in this module because we assume you already know. Okay, yeah. So at the end, you arrive at 81 point something, 10 power 3 kilonewton. So again, let me see here. Yeah, correct. So you'll get a megapascal. Yeah. So, all right. What else? So on the screen here, the E here you can straight away write 10 power 9 Newton over meter, and then you do your calculation. Yeah. This is just a illustration of another way that you can calculate. Okay, so this is quite straightforward for this kind of question. Yeah. Let's see. Okay, before we go to plane stress, any question for this tutorial question? Anything that doesn't make sense to you? Nope. Okay. If no, then let me stop the recording.